Okay, we're going to talk about section 10.5 today. This is applying other angle relationships. Okay, first thing we're going to do is we're going to go ahead and review some of the vocabulary we know. First thing we want to do is we want to review what a tangent and a chord is. Okay, if you remember from your vocabulary, the tangent is a line that hits exactly one point of a circle. Okay, so on this particular diagram, tell me what your tangent line is. That's right, tangent line is BA or BF, however you want to look at it, but right here is your tangent line. Okay? And then your tangent, or point of tangency, is going to be A right there. Alright? And a chord, if you remember, is where it's a segment with both endpoints being on the circle. So where is our chord? What segment is our chord? That's right, CA is a chord because our endpoints are A and C, and they're both placed on the circle. Now, let's review the two types of angles. Okay, we know of a central angle. What does a central angle look like? Right, a central angle is an angle that comes from the center of the circle. So something that may look like, well, not that, something that may look like this, that would be a central angle, okay, because it's coming out of the center. And then of course you have an inscribed angle. What does an inscribed angle look like? Right, an inscribed angle, if you remember from just a unit or so ago, it is where your point, your vertex, is on the circle, and something that looks like that. That's an inscribed circle. When we're talking about the central angle, what do you know about this angle measure and the measure of the arc? Yeah, they're the same, right? So the angle measure for the central angle and the measure of the arc are the same. When we're dealing with an inscribed angle, what do you know about the angle measure and the arc? Well, the angle measure is half of the arc, or the arc is 2 times the angle measure, right? Okay, so that's just a little bit of review. Now if we look at our diagram now without all the markings, what you'll notice is you have a chord and a tangent creating an angle. Okay? If I give you arc CEA, okay, so CEA right here, and we also have this angle here created by the chord and the tangent, sorry. If I give you arc CA being 224, okay, can I figure out the measure of angle BAC? And again, BAC is right here. Can I figure out this angle measure given the arc measured 224? Well, what we're going to do is we're going to treat this, even though it's not exactly like the inscribed angles that we're used to from the couple sections before, we're going to treat it the same as an inscribed angle. So if you remember what the inscribed angles do, you would take half of the arc angle. So in order to get this measure of angle BAC, you're going to do 224 divided by 2. So 224 divided by 2 is going to give you an angle measure of 112. Now, let me clean some of this up here. Looking at our diagram now, we have this being 224, this arc here. Okay, we just figured out this angle right here was 112. Now I want to figure out what angle CAF is. So what's this angle measure right here? Well, what do you notice between angles BAC and CAF? What kind of angles are they? Well, if you said they're supplementary, that would be true. Okay, that is true. This also means that they equal, angles equal 180. That would also be true. They're also adjacent. Okay, so if they're adjacent and supplementary, okay, what do we call those angles? Just kind of a review. That's right, they are a linear pair. Okay, because they create a line, right? So with that being said, if they're adjacent, supplementary, create a linear pair, it should be pretty easy to get what this angle measure is. You simply just do 180 minus 112, and you end up with 68 degrees. Okay, now I want to get the measure of arc CA. So what's this arc measure here? Well, if this is 68 degrees, and here, this is our intercepted angle, right? I'm sorry, intercepted arc. If we cut 224 in half to get 112, then how are we going to get this arc measure? That's right, if you said multiply 68 by 2, you'd be correct, and that would end up with 136. Okay, so essentially when we're dealing with a tangent and a chord, when they create an angle that may not necessarily be completely inscribed, you're going to treat it as an inscribed angle. Okay. And as always, if you have any questions, please come see me in tutoring, ask me in class, or see me after school at PASS. All right. What if we're dealing with the angle intersection of two chords? So here you have two chords, chord CH and chord BD, and they're both intersecting. Okay. What we're going to do in order to figure out the measure of angle CFB, okay, and angle CFB is located right here, CFB, is we're going to take the average of the two arcs, okay, and we're going to use the vertical arcs. The vertical arcs, like a vertical angle, are the ones right across each other. So here's a vertical arc, 105 is across from 68, okay. So angle CFB then simply is going to be the average of the arcs. So I'm going to take 105 plus 68 and divide it by 2. So that's going to be 173 divided by 2, which is going to leave me with an angle measure for CFB equal to 86. Rangers are getting killed right now for those of you guys listening in. 86.5 degrees. Now I know that on your notes, if you have the pre-printed notes out in front of you, it says 86 degrees, and that's because they just rounded. This program that Miss Wilson used last year went ahead and rounded for you to the nearest degree. But the accurate answer is 86.5. Okay, so now if this is 86.5, using our vertical angles theorem, we know that this is also 86.5 or 86. Okay, well, if this is 86.5, what is this angle measure right here? Well, you just subtract that from 180, and you get 93.5. And then, of course, across from that would be 93.5 as well. Okay, so that's the angle intersection of two chords. Again, you take the vertical arcs, 105, it's 68 in this case because those are the ones given to you, add those together, take the average. So 105, 68, add them together, divided by 2, 173 divided by 2, 86.5. So essentially that angle measure there is the average of the two vertical arcs. Okay? Alright, moving on. One thing you'll notice that when we were dealing with our angles, and we started with the vertical angle, the central angle, as we moved out to a inscribed angle, you notice that this angle was bigger, and then it got smaller, and then now as you continue to move out, and again, just think about a rubber band when you do this, it continues to get even more smaller, and so the further out it gets, the smaller that angle gets, and so now we're looking at a different type of angle. Okay, so let me clear this up a little bit. The question is, how did I get angle ABE, which is this angle here, to be 28 degrees? If I'm given that this arc measure here is 37, and this arc measure here is 92. I want you to take a second to pause the video to see if you can't figure out that. I talked to one of the classes today, or a couple of the classes today, about using the back of the textbook. You can use the back of the textbook to help you check your answers, but one of the other things you can do is if you're completely lost with a topic or a question, you can get the answer ahead of time, like we're doing here, and work backwards and try to see how you can figure out how we got the answer. So if this is my answer, 28, using the information given here, figure out how you got 28. So pause the video and see if you can figure that out on your own. Okay? Maybe you came back now, and what you're going to notice is that what you did, in order to get 28, okay, hopefully you noticed that what you ended up having to do was very similar to what we did before. Earlier we just averaged the vertical arcs together. So we took the two arcs and divided by 2, but now you have an extra arc. So you have your angle measure, and then I would call this right here, that 37, an extra arc, and then you have your big arc out here. Obviously you're not dividing 92 by 2, because that's not going to get you 28, but maybe you noticed that you took the big arc and you subtracted the little arc of 37, and then you divided by 2, which is where that similarity with the last setup comes from. So 92 divided by 37, 92 minus 37 is equal to 55, and this might have thrown you off if you were trying to investigate this on your own. Divide 55 by 2, and you don't actually end up with 28, because again, this rounded for you, end up with 27.5. But in any case, that is our setup. We're always going to take the big arc and subtract the little arc, or the extra arc, to get our angle measure. Okay, so plugging in what we just did, we did 92 was the big arc minus 37 divided by 2. So, and then we ended up with 55 divided by 2, and 55 divided by 2 is 27.5, or rounded to the nearest degree is 28 degrees. Okay? Pretty easy. Alright, last but not least, very, very similar situation here. Okay, on this one we're going to actually do two different examples using the same thing. The first thing I want to do is let's go ahead and identify some of the arcs that we see here. This is very similar to the last problem, like I said earlier. Okay, let's identify the two arcs that are in play here. The first arc is very easy to see. It's this arc right here, arc RS. Okay, arc RS, is that a minor or major arc? Okay, well, it looks clearly to be a minor arc. So we're just going to name this arc RS. The other arc that seems to be in play, if you look there and analyze this diagram, is you're going to see arc RTS. Okay, arc RTS. So is arc RTS a minor or major? Well, it looks to be a major arc, so we're going to label it with the three letters, RTS, to give us directionality. Okay, now between the two arcs, RS, so arc RS plus RTS, arc RTS, you're going to get 360 degrees, right? Okay, it's going to be important when we get into this in just a second. We're going to still use the same format, so if I'm looking for angle RVS, okay, so if I'm looking for this angle, I'm still going to do what I did on the last one. I'm going to take the big angle, the big arc minus the little arc. So I'm still going to take arc RTS minus arc RS and divide it by 2 to get the measure of angle RVS. So if I give you angle RS being equal to 99 degrees, in order to follow the notes that some of you might have right in front of you, how can I figure out what the arc measure of RTS is? Right, I'm just going to do 366 minus 99, and that'll give me that arc RTS is equal to 261 degrees. Now if I use my formula, I can easily figure out what RVS is. I'm going to take 261 minus 99 divided by 2. It's going to be 162 divided by 2. And that's going to give me 81 degrees. So the measure of angle RVS is equal to 81 degrees. Okay. Now, what if I gave you, I'm going to clear this off a little bit. What if I didn't give you a number for angle RS? What if I said that angle RS was actually equal to X degrees? What is the angle RTS equal to? Yeah, hopefully you figured out angle RTS is equal to 360. I'm actually going to write it below here. 360 minus X, right? Because, again, these two angles together, RS and RTS, equal 360. That's what we put up here. So if I say RS is equal to X, I'm going to have X plus RTS. To solve for RTS, I have to subtract X from both sides, correct? Correct. Okay. So how would I set up finding our measure of angle RVS? Yeah, the same way. I'm still going to do arc RTS, which is 360 minus X, minus arc RS, which is X, divided by 2 is equal to the measure of angle RVS. Now, unfortunately, I can't go any further with that because I don't have enough information to solve for anything. But what if I was given angle RVS to be equal to 24 degrees? Now this should give me enough information to solve for X. So when I solve this together, I'm going to have 360 minus 2X divided by 2 equals 24. Okay, I'm going to move this to another page so that we can have more room to work. So then as I continue to work this problem here, I'm going to end up with 360 minus 2x is equal to 48. Continue to solve for x. I'm going to have negative 2x is equal to negative 312, because that's 48 minus 360. Divide both sides by negative 2. And x is going to be equal to 156 degrees. So that's what x is equal to. So then if you go back to your diagram, that means that arc RS is equal to 158 degrees, which actually makes sense because it is a minor arc, so it's less than 180 degrees, correct? Alright, and that is pretty much it for tonight's lesson. If you have any questions, again, come see me. Other than that, have a great evening.